thank you for the invitation to be here. It's our pleasure to present at this webinar today. So what we're going to talk about is the demonstration of the new random effects methods in RevMan. And this is the second webinar in a series of two. So the first webinar we held last year was in October. And what the purpose of that webinar was to really talk about the process used to develop the recommendations for the random effects methods that have been implemented in RevMan. And in that webinar, we also outlined what the methods were, along with the reasons for why the particular methods had been selected. And this QR code will take you directly to that particular webinar. But it's very easy to search. If you just search the methods support unit random effects, then you'll find your way very quickly to this webinar. So the purpose of today's webinar is to demonstrate the new random effects as they have actually been implemented in RevMan. And so what we're going to do is give a brief overview of the random effects methods, which have just very recently become available as of the 23rd of January this year. And this is very exciting for us because in the Cochrane Statistical Methods Group, there's been a team of people that have been working away for many years trying to consider what methods should be implemented. And so it's very nice for this to come to fruition, and lots of people have been involved in this process from obviously the RevMan team and the broader Cochrane team, as well as the conveners of the Statistical Methods Group and other people who've importantly contributed in that process. And then we're going to move on to demonstrating the methods using RevMan, including what method might be used in which scenario. We're going to cover confidence interval methods for the summary mean effect, heterogeneity methods, and a confidence interval for the heterogeneity estimate, and the prediction interval. And then briefly, we're going to conclude again with some considerations for what to write in the protocol and review report, and then we'll have some time for questions. So obviously what we're going to touch on today is briefer than the information that's now actually contained within Chapter 10 of the Cochrane Handbook. So this was updated at the end of last year, and you can find out about these new methods in more detail and some of the rationale for why we are suggesting to use particular methods in particular scenarios within that chapter. What I'm going to show here is a diagram that will keep reappearing throughout this presentation. On the left-hand side here, we have the quantity to be estimated. What the meaning of that is will become clear shortly, and then the statistical methods and recommendations implemented in RevMan to estimate that quantity. So the first three methods we have here is tau squared, a confidence interval for tau squared, and the I-squared statistic, the confidence interval for the summary mean, and the prediction interval for the summary mean. And what we have over on this side is really the kind of what are the default options, and also some of the details around which particular method would be selected in which scenario, which particularly applies to the confidence interval for the summary mean. And we will talk through the specific details of this. So what I'm going to do now is hand over to Arji, who's going to take over from this point, and I will reappear near the end of the presentation to talk about prediction intervals. Thanks, Arji.
Okay, wonderful. So I believe you can see my screen. Okay, just a moment. Okay, wonderful. So thank you once again, Joe, and hi everyone from me too. So as Joe already mentioned in the previous webinar, we explained the methods and recommendations, but today we're going to show how we can perform those methods in RevMan. And the updated RevMan was released, as Joe nicely pointed out, last week actually, January 23rd. And hopefully the new additions will be helpful to the reviewers to get better and valuable and valid outputs. And here we also present a QR code for some additional guidance on the analysis steps in RevMan in case you're interested in exploring this further. So let us start by considering that we have this data set. on acupuncture for dysmenorrhea with those 6 studies. So here the data include the mean, the standard deviation, and the sample size on intervention and control groups. And the study results are provided on menstrual symptom score. So given that the data have been abstracted and we are ready for the analysis, what we need to do next is to enter this data into RevMan and then start applying the meta-analysis methods. So in the next few slides, we will show how we can fit the standard options existed up to now. And these are the Dersimon and Laird for estimating heterogeneity and the Wald type method for obtaining a confidence interval for the summary effect. And then we will also show how we can apply the new and recommended methods, which are restricted maximum likelihood to estimate heterogeneity, and the Hartang-Knapstedt-Jonkman method to calculate a confidence interval for the summary effect. So later in the presentation, we will also present how we can obtain prediction intervals, and Joe will talk a little bit further about this and what we need to write in the protocol. So starting with adding the dataset in RevMan, this is how it looks like. In the analysis section and the data tab, we can add the data that we had earlier. So for example, if this data were available in an Excel file, we can add them in RevMan. And here again, we can see the 6 studies with their mean, standard deviation, and sample size for each of the groups, the intervention, the control group. And then at the last column, we can see the mean difference results along with the 95% confidence interval for each of the studies. And at the bottom of the data set, we can see the pooled effect based on the analysis that we chose or were already pre-selected. But this is going to change according to the analysis settings that we choose in the next step. So this is the information that is presented under the data tab. Next, we're going to see the options tab. And here we can see in the beginning of the page the name of the analysis, the data source, if this is going to be automatically or manually for the data to be added. Then we see the data type, and here in our example, we have continuous data. And finally, the intervention groups, which here in our case correspond to the acupuncture and medication groups. And then if we scroll a little bit down, we will see the statistical settings, and this is what we're going to discuss in the next slide. Okay, so in the statistical settings, we start with the statistical method. And in the statistical method, we can choose between the inverse variance, the Mantel-Haenszel, or the Peto methods, depending on the analysis model that we would like to choose. And then we can choose the affect measure of interest. Here, for example, this is the mean difference. And then we move on to the analysis model. So here we have, as previously, the fixed effect and the random effects models. Now, once we choose the random effects model, more analysis options open, and these are what we are going to discuss today. So we start with the heterogeneity estimator options. So these are the Dersimon and Laird and the restricted maximum likelihood. And the pre-selected option is the restricted maximum likelihood. But if needed, we can change this to Dersimon and Laird. And then you can see we have a checkbox on whether we would like to present the confidence intervals for heterogeneity. And this helps us to see the uncertainty in the tau square estimation and helps us explore where the true heterogeneity value lies in. So we click on this if we want to get this information. And then we have the totals and subtotals. So if we need, we can select subtotals only or no totals at all. And this would correspond to just the presentation of the study results. Okay, so then we have the option to check the checkbox to show the prediction interval on the total summary effect. And Joe will explain this in detail later. And we can also change, if we are interested in a different level of confidence, we can change from the 95% to 90 or 99% for both confidence intervals and prediction intervals. And finally, we have the option to select the method to calculate the confidence interval for the summary effect. And the pre-specified option is in RevMan will be the new method, the Hartung-Knapseding-Jonkman method. But if the reviewer would like to change this according to different analysis needs or the review's needs, this is also something that we can do. And at the end of the section of this web page, we may see highlighted in blue pop-up like this one, which is a note for the reviewer to remind what are the Cochrane recommendations in case we choose something different. Such as in this case, what is the advice to do when heterogeneity is 0 or positive? And let's see again the recommendations on this aspect. So going back to the part of the recommendations for the confidence interval that Joe showed earlier in the overall slide, we can see that for a tau square above 0 and for a larger number of studies than 2, the Hartung-Knapseding-Jonkman is recommended. And this is a method that is designed to calculate more accurate confidence intervals for the summary effect. So this is exactly what is shown in this highlighted in blue pop-up, but we will get into the technicals. We will not get into the technical details today because, as we said earlier, that these were presented in the previous webinar. But we're going to see some examples on these aspects. So this is the message that appeared because in the summary confidence interval method we selected earlier, the wall type method. But based on the recommendation, when heterogeneity is above 0, then we need to change this to the newly added method, the Hartung-Knap. Now, changing the option from wall type to the Hartung-Knapseding-Jonkman method, we can see that now the pop-up disappears. And then moving to the third tab, that's the graphs tab, we can see the forest plot of the included studies and according to the selections that we made in the analysis. Now, at the end of the forest plot, we can find all the details that we selected to be used as footnotes. And we see, for example, here the confidence interval and the tau square methods that were used in this meta-analysis. Also, at the bottom of the forest plot, we can see the heterogeneity values, the tau square, showing also the method chosen. Here is the DL, the Simon and Laird, the 95% confidence interval for heterogeneity, the chi-square, and finally the I-square, which is calculated according to the heterogeneity method that we chose. So we expect that the I-square value will differ if we change heterogeneity estimator. And all these details are also described in Chapter 10 of the Cochrane Handbook. Now, to refresh our minds, let's go back to the recommendations. Now, the default option for estimating tau is the restricted maximum likelihood. And this is the recommended option and offers a more reliable estimation of tau. But there is also the option to choose the Simon and Laird if that's of interest. Then we can also select to display the confidence interval for the heterogeneity, the tau square, which is optional here. And as we said, we can check the checkbox that we showed earlier if we're interested in presenting this. And finally, the I-square statistic is calculated using this formula. It actually uses a tau square as estimated with a method chosen in step 1. So we expect that this will differ according to the estimation method that we used, a restricted maximum likelihood or the Simon and Laird. Now, in case we hadn't calculated this confidence interval for heterogeneity, but this is of interest and important for our interpretation of results, we can go back to the Options tab and select this checkbox. In this case, now I may also want to choose the recommended method for estimating tau square. So I may want to choose the restricted maximum likelihood. I'm also able to make those changes at this point. Now, going back to the Graphs tab, we can see how the updated forest plot looks like. Again, at the end of the figure, we can see in the footnotes that the restricted maximum likelihood method has been used. And then at the heterogeneity information row, we can see that heterogeneity now is higher. Heterogeneity is equal to 2.82, whereas previously it was estimated as 1.43. And we can see that the I-square has changed as well. So it increased from 89% to 94%. And that's, as we said, because this was recalculated according to the restricted maximum likelihood estimation. Overall, heterogeneity, the tau square and the I-square have changed in this example, but the confidence interval for the tau square remains the same. And that's actually expected because this calculation is irrespective of the tau square estimation method that we used. Now, in this slide, we present the results and forest plot presentation of the three analysis options that we selected earlier. So first, we see the finding when the De Simone and Laird and Wald type methods were used as per the standard options that RevMan had up to now. Second, we see the finding when we change the confidence interval method for the summary effect to Hartang-Knapsen-Jonkman. And as we can see, and as expected, the confidence interval is wider than earlier. And third, we can see the finding when we also decided to go with the recommendations, the recommended methods for estimating heterogeneity and the confidence interval for the summary effect. So the De Simone and Laird, as we said earlier, estimated tau square as 1.43, but then the restricted maximum likelihood estimated tau square as 2.82. And this is also, as you can see, reflected in these I-square values. But as we said earlier, this confidence interval for the tau square remains the same. And we can see that it is actually quite large, ranging from 0.82 to 19.51. Now, as mentioned in the previous webinar, it is often the case that De Simone and Laird underestimates heterogeneity, the tau square. And let us actually now see this example that we discussed in the previous session, where we had 5 studies and De Simone and Laird estimated heterogeneity equal to 0. Now, this information is also shown at the bottom of the first tab, which shows the data. Now, taking a look at the top of the data, there is a pop-up highlighting in blue, and that's for our attention to make sure we don't miss this information. So it says that the heterogeneity, tau square, is equal to 0, and the Cochrane's guidance to use the Wald is to use the Wald type method to calculate the summary effect confidence intervals in this scenario. So originally in this, in the analysis options, the De Simone and Laird and Hartang-Knapsen-Jonkman methods were selected, but in this pop-up, we see that it prompts us to update the analysis choices. And as mentioned in the previous webinar, the De Simone and Laird frequently underestimates tau square, and this will also impact on the confidence interval for the summary effect, and therefore it will become too narrow. So here we present a typical example that shows what will happen in RevMan and if we choose the Hartang-Knapsen-Jonkman method when this tau square is equal to 0. Now, going to the Options tab, we can see that the node appears both at the beginning of the page and at the end of the page. So as you can see, the choices for this analysis were the De Simone and Laird and the Jonkman methods. So next, going to the third tab, we can see again the pop-up, and this prompts us to change our selected methods. In the forest plot, we see clearly that the De Simone and Laird estimates tau square equal to 0. However, the confidence interval for the tau square as calculated on the odds ratio scale for study effect sizes, it ranges between 0 and 1.30. So this indicates a quite wide confidence interval and suggests that heterogeneity can be even up to 1.30. So it would be reasonable in this case to change the estimator and use the different one rather than the Dersimone and Laird. However, let's say for now that we would like to keep the Dersimone and Laird option. But then the pop-up recommends in that case that the wall type would be the best method to use instead of the Hartog-Knapp method for the summary effect. And this is based on the properties that we discussed in the previous webinar. So going back to the analysis options, we can change from Hartog-Knapp method to wall type method, and we can see now that the node disappears. So using the Simon and Laird here, which estimated heterogeneity equal to 0, it is more appropriate to use the wall type method for the summary effect. Now, comparing the results of the two analysis options between the standard previous approaches and the newly recommended approaches, we can see that the Dersimone and Laird with the wall type method gives us a shorter confidence interval for the summary effect, whereas the restricted maximum likelihood with the Hartog-Knapp method is wider, as it is actually expected. So in this case, we would apply the recommended approaches, the restricted maximum likelihood and the Hartog-Knapp methods. Now, in the case of 3 studies, as discussed in the previous webinar, the Hartog-Knapp-Jonkman method can sometimes be very wide, and as we can see in this example. And if we select the wall type as the method of preference, then we still get this pop-up with the recommendation using the Hartog-Knapp-Jonkman method. But in case you decide to not perform the Hartog-Knapp method, you would need to explain with a valid rationale why you prefer to proceed with not choosing the Hartog-Knapp, which is the recommended approach. Now, if you remember from our previous discussion in the previous webinar, in most of the cases where the meta-analysis included 2 studies, the Hartog-Knapp-Jonkman method becomes overly wide. And in this case, this confidence interval is not informative anymore. So in these cases, Cochrane recommends to use the wall type method. So in cases of 2 studies, we can use the wall type method. In RevMan, when we have 2 studies in the meta-analysis and we select the Hartog-Knapp-Jonkman method, then we can see that we get a pop-up and this appears saying that there are only 2 data rows contributing to this analysis. Cochrane's guidance is to use the wall type method to calculate the summary effect confidence intervals in this scenario. Now, going back to the schematic representation of the recommendations and the part of the confidence intervals for the summary effect, we can see that when tau square is positive, then we need to check what the numbers of studies is in this meta-analysis. So in case of 2 studies, when we have only 2 studies in the meta-analysis, then the recommendations say to use the wall type method. And changing the method to wall type, this is also updated in the forest plot, presented in the 3rd tab, in the footnotes of the plot. And this helps us see the method that we applied earlier during the analysis process. So I will stop here and I will pass it over to Joe for more details on the prediction intervals. Thank you, Joe.
Great. Thank you very much, Arji. Okay, so what I'm going to talk about is prediction intervals. And before I talk through the specific implementation of those in RevMan, I just thought I'd briefly mention what they are because I think there's something that's probably less familiar to many review authors. Prediction intervals are an interval that really describes the dispersion of true underlying intervention effects. And it can be something that is more interpretable than just looking at your estimate of tau squared or even your the I-squared statistic. And what it tells us is it tells us about it's an interval that tells us about the summary of the true spread of underlying intervention effects. So we'd expect most studies that would be eligible for that particular meta-analysis to fall within the lower and upper bound of the interval. And it's distinct from a confidence interval, which is telling us really around how certain we are in estimating the average effect for the meta-analysis. So that's a very brief summary of what a prediction interval is. How it's implemented in RevMan is, first of all, it's an optional feature, and we don't recommend that a prediction interval would always be used because you do need a reasonable number of studies to actually calculate a prediction interval. But if you decide to calculate prediction intervals, then the particular way the prediction interval is calculated will be dependent on the method that's been used in the calculation of the confidence interval. So, for example, if you've used the Hartung-Nack-Siddick-Jonkman confidence interval method, then the prediction interval will be calculated using a t-distribution and the multiplier. If it's the case that you've used a Wald-type confidence interval, then the standard normal quantiles will be used in the calculation of the prediction interval. And the method that you have used to estimate tau squared will also be used in the calculation of the prediction interval. Under the options, you can just select the prediction interval. There is a tick box at the bottom, and you can also specify the particular level of that confidence and prediction interval, I should say. And here's an example of one. So what you can see here is we have our estimate of the summary mean effect. In this case, it's an odds ratio of 0.32, and that's depicted using a diamond. A prediction interval is depicted using a different symbol, just a straight line in this case. And that is because we want to make it distinct from the confidence interval because it does have a different interpretation, obviously. And what you can see here is the prediction interval in this case is slightly wider than the confidence interval because the prediction interval is telling us about the dispersion of the true underlying intervention effects for studies that are eligible for this meta-analysis. And so in this particular example, if the outcome, suppose, was mortality, then what you would see from this, you'd be able to interpret is that in most settings, the particular intervention looked to be very beneficial in terms of reducing mortality. And these are the other ways of kind of presenting information about the dispersion of intervention effects. We have the estimate of tau squared, but just looking at that estimate, it's not overly interpretable. And we have the I-squared statistic, which is telling us something quite different to a prediction interval. It's telling us about the proportion of variation that's due to heterogeneity rather than chance. Just a short note to say this slide here really shows 2 points. The first is that the prediction interval will equal the confidence interval when tau squared is equal to 0. And it also shows that the particular confidence interval method will determine something about how the prediction interval is calculated. So in this case, the Wald-type confidence interval method has been used. So the prediction interval has been calculated using the normal distribution quantiles. And what you can see here is because our estimate of tau squared is 0, essentially our prediction interval just collapses back to a confidence interval in this particular scenario. Okay, so we kind of touched on this a little bit in the last webinar, but thinking about the considerations for what to write in the protocol and the review report. The first thing is that if you're setting up a new review from scratch, then I think you really do need to be aware of the random effects methods that are now available in RevMan and the recommendations around about what method should be used in which scenario. And this should really be written into your protocol. Prisma 2020 is helpful for guiding what to report, even for guiding what to report in the protocol. There's obviously a Prisma P extension, but that's in the process of being updated. And at the moment, Prisma 2020 perhaps provides more kind of detailed guidance. So I just want to touch on item 13D, which is about describing methods used to synthesize results and provide a rationale for the choice. And then within that item, there are elements that provide much more detailed guidance around what you should report. So the meta-analysis model, the method used, methods used to identify or quantify statistical heterogeneity, and the method, the between study variance method that you'll use, and the method used to calculate the confidence interval for the summary effect. And something additional here is really thinking about that algorithm that's going to kind of dictate which method you use in which circumstance. I think that's something that's important to include. So I'm just going to start with an example here of what you could write something like. The first thing here is that you would specify the particular method you'd use to calculate the between study variance. So in this case, it's the restricted maximum likelihood method. And then you would say, for example, if you plan to calculate a confidence interval for the heterogeneity estimate, you could say that here. You could actually go further and say something about the specific method, but there is only one confidence interval method for heterogeneity estimates available in RevMan at the moment. And then I think this is the really key part here, is really describing what you're going to do dependent on what you estimate. So the Hartung-Knapp-Siddick-Jonkman method will be used to calculate a confidence interval for meta-analysis effect estimate when there are at least 3 studies and the estimate of heterogeneity is greater than 0. In other scenarios, that is when there are 2 studies or with estimated heterogeneities equal to 0, we will use the wild type method. So that really describes the algorithm that RG has gone through and where the pop-ups are going to kind of direct you as to which method you should use. And then if you plan to use prediction intervals, obviously saying something about the fact that you will do that, and also the circumstance and when you would use a prediction interval. So are there a minimum number of studies when you would actually, for which you would need before you would calculate a prediction interval? I guess be sure to avoid fitting multiple meta-analysis methods and reporting the results that are most favorable to your kind of review story. Obviously, historically, with RevMan, we only had one random effects method with the Dersimonian Laird estimator and the wild type confidence interval. So that really prohibited selecting amongst different random effects methods. Now that we have multiple available, you need to be very careful about kind of pre-specifying what you'll do and following that plan. Of course, there can always be circumstances where you can end up with some unusual results. And I think one of the examples that RG showed where there were 3 studies and the Knapp-Hartung method had been used and ends up with a really, really enormous confidence interval. There are some quirky things that can happen with that Knapp-Hartung method when you have few studies. And in those studies, it might be preferable to actually present both the wild type and the Knapp-Hartung methods because you're actually just very uncertain when there's a lot of disagreement between the wild type and Knapp-Hartung. You're very uncertain as to which one is right. In fact, you just don't know which one is right.